Hi, my name's Anil Sharma. I'm a data science manager at Klarna. I've been there for 1.5 years now, and I'm really happy to share this story with you. It's about, you can read the title, our journey with recommendation systems, where we went from nothing to something. And I want to set the expectations at the right level at the beginning. I'm not going to talk about how we've developed a new whiz-bang algorithm or we've implemented it. What I'm going to talk about is a journey of about 12, 13 months where focus on customer value, iteration speed, and testing hypotheses have reaped really strong results. I hopefully inspire you to do the same. But you might be wondering, why is Klarna working with recommendation systems? So in the last few years, Klarna has invested heavily in becoming a shopping destination. We want to be able to basically help customers find the products and services that will enrich their lives and buy them through Klarna. So this is our app, and in the app you can search for products and go to the merchant website in the app and pay for them there. If you're not sure what you want, we also provide this inspiration feed where we show you different products and groups of products which will hopefully help you find what you want, even if you didn't know you wanted it to begin with. You might also be asking, why would you do this? Well, in the Klarna app, an advantage is if you go through and buy something using the Klarna app in a merchant that doesn't offer Klarna as a purchasing option, we can create a one-time credit card. You just press a button and you pay the merchant with that, and then it's for you just like a normal Klarna purchase with Pay Now, Pay in 30, all the other Klarna purchasing options. I'm going to take a second now to talk about one major part of this feed, which are created shopping lists. So these are hand-picked lists of products, which are then categorized by theme, and they're all shoppable. So here we have the customer journey, where you go from the top left. These are the curated shopping lists. You click on that one, and you go to then a list of products. You click on one of these products, and you go to the merchant's website, but still within our app. So we can do things like this, create the one-time credit card, or even fill in your details for you on checkout. But now, onto the story. So it's October 2020. 2 teams have just joined to become one. And our remit is to first work on making a better ordering or personalization of these created shopping lists in the app. Then to work on product recommendations for customers, so much more personalized product recommendations for customers. And then over longer term, being able to personalize any type of content. The state of play then was we had these created shopping lists, and once a week, someone would go through and see which ones were the most popular in the previous week, write down those in a list, and that's what was displayed to everyone, those top 12. On top of that, we had and still have an onboarding questionnaire where we ask you about your interests. Those created shopping lists were tagged with interests, and that's how we also ranked for those people that have told us which created shopping lists you also saw on top of these top performing ones. So that's the baseline when we started. Should also say, so the 2 teams became one. The data scientists were either new to Klarna, like me, or new to recommendation systems in Klarna, whereas the engineers had been around for a while in the respective teams, and they had a backlog to work on. So all of this was rules-based, written TypeScript in a Node.js backend server, and we didn't have much hope of getting a model in Python in a REST API to be called from that in the near term. So what did we do? Well, we wanted to make an impact, and we wanted to start testing our hypotheses. What do our customers actually want? What data do we have that is useful, and what can we do with it? The engineers were quite busy, still very busy, but how can we even begin to test? It's like, well, what about if we have a table in this backend service which these rules could then interact with as like either a set of weights or even like a lookup table. For this customer, show this content. Talk to the engineers. Yeah, that sounds reasonable. So how do we do this? Well, if we have a CSV file, put that on an S3 bucket. We work in AWS. That gets put into the service, and then the rules get updated. They're small updates. And the engineers were fine with this. They also wanted to make an impact, and this wasn't going to get in the way of them working off their backlog. The first test we did was trying to figure out, well, some of these interests have a higher click-through rate. Our click-through rate is our biggest KPI. What if we also rank by click-through rate of the interest? If you select 10, let's take the top 3 with the highest click-through rate. It didn't work. But the most important thing was our team learned how to methodically set up, execute, and analyze A/B tests, and it allowed our data scientists to be able to start testing our hypotheses while we waited for the infrastructure to be built, which let us run 7 different A/B tests over a period of 3 months. Each test ran over 1 to 2 weeks. They were really tight on each other. We tested, we had a really sharp focus on testing hypotheses, not just, oh, let's try a bunch of different algorithms. Over time, we actually managed to increase the click rate in the whole shopping app by 10%, even though we were still at a really early stage testing hypotheses. What do our customers like? Half the tests didn't show an improvement. But we did start moving forwards at an accelerating rate. But you're probably guessing that having a model, hand-trained, manual output in a CSV file which gets loaded up into service is kind of hard to have in production and maintain in production. By this time, our engineers had worked off the backlog and they were able to really pitch in. And that's where we started with automated model deployment. So not just automatically training and evaluating the model, but also putting it up into a REST API automatically. So getting a loop of new data, a newly trained model into production, serving our customers. So apart from freeing up data science and engineering time by having this step automated, why else would we want to do this? Well, recommending in e-commerce, things change on at least a daily basis. We get new products, we get old products that are out of stock or discontinued. We have new customers. These creative shopping lists we're working with, they were changing on a daily basis. So the data Klarna was creating was changing. We get new customers continuously, and the customers are giving us feedback, and the quicker the loop between them giving us feedback, us responding to it, the better their user experience. So to start with, we say, okay, can we get new data, retrain the model, check the metrics are at least as good as the previously trained model, put it into production. And we did this. This is something you don't need to really care about, but this is the first diagram that we had, and it's an unholy alliance of Jenkins and AWS Lambda functions. But it worked, and it still continues to work. And this, I think the most important part was the outcomes. So one of the things we tied when we're doing all these A/B tests was, what about a simple collaborative filter model? And this is something from like the 90s, matrix factorization. The loss function's a bit more new, warp loss. This is one of the tests that worked. Can a simple personalization model work for our customers and our data? Putting this into this automated training and deployment pipeline increased the effectivity over that over 2 weeks, 2-week experiment, by 5%. So in click rates went up by 5%. Same model, just fresher data every day. Actually, the delta between the manual and automated solutions increased over time. But over the 2 weeks on average, it was 5%. I think Really cool though, having this also enabled us to start using simple models, simple reinforcement learning. So here we use Thompson sampling, something from the 50s, if I remember correctly. So if you remember, the baseline here is the human going in, checking past performance. So that's what we were trying to at least get as good as, to stop them having to do that work. It was taking 140 hours a year to do this for 5 markets. We're expanding into many different markets, and that team didn't have the time to do that. Having this automated procedure let us get rid of that person's work. They can concentrate on higher value work. Enabled rollout to new markets. So as soon as the new created shopping lists are in the market, we start already having them go through this model. And it actually increased the click-through rate by 25% over an already decent baseline. And it wasn't just clickbait. So the products within the created shopping list, so you click on the list, it goes through a list of products. People will also click on those at an increased rate, 11%. So again, a simple model achieved pretty good results. By this stage, we've got a new baseline for these created shopping lists, and what we were really interested in were product recommendations. And where we started, we wanted to start in the app. You get a lot more feedback and a lot more quickly. But building the loop to get high quality data to these services, to the app, wasn't there yet. But it was there for emails. So for transaction emails, this is in the US market. So you buy something with Klarna, we send you an email saying, hey, you bought this thing. A lot of people in the US also use pay in full. So you also get 4 follow-up emails saying, please make sure you pay in time. So we can send out 5 emails for every transaction. It's not the best setting, I have to admit. So, hey, you bought this thing, why don't you go back to that place where you just bought it and buy some more? Or, hey, remember to pay us, now go out and buy something else. But it still managed to get a fairly decent rate of return, showing that we can, based on people's previous purchases, make personalized product recommendations, and that was providing some value. And I should say, the model for this was, again, using matrix factorization. We got the latent factors from the items, made a simple item-item recommender system. Then we just looked at what were the things you just bought, used lookup on that. So super simple. Then we wanted to, of course, make recommendations in the app homepage. But then the question is, do people want this? We're already giving them organized lists of products. Does showing them products on this first part of their journey actually provide them any value? The way we thought, and actually did plan to test this, was we said, okay, why don't we get those products that are in these lists and surface them in the first step of the user journey? And if that works, then that would be a good signal that we should proceed and make better product recommendations here. So what we did, we used the same Thompson sampling, so reusing much of the same code, figured out what were the most top-performing products in these CSLs, surfaced them here. We got a 5% increase in clicks and 11% increase in virtual credit cards. So this, if you remember, in the user journey, is where you say, hey, I want to buy this, create a one-time credit card. So a really strong signal people were increasing their purchases in the app just by showing these products a bit earlier. Now we wanted to personalize these and say, okay, but how do we test if personalizing this is going to provide some value? Well, we've got these onboarding questionnaires with other interests. The products are also tagged with these interests. Why don't we re-rank based on what people have told us? We got a 17% increase in click-through rate for these customers that have told us their interests, showing that, yeah, okay, if we do even a simple personalization in the app homepage on these products people can already get to in the app, we get a much higher engagement. So this is October 2021. The next month is November, which has Black Friday, Black Week, which is a really high volume period for Klarna. At this point, we say, okay, we've done a lot of testing over a year. How can we scale this to have the most impact? The first thing we looked at was more touch points. So marketing, instead of transaction, we have marketing emails and push notifications. This again started with a CSV file. We shared, hey, these are the most popular products. It was used in a push notification for reactivating customers. Strong response. So, okay, how can we automate this? We made a link between our model APIs, the marketeer system, Braze, and now every time they want to do a campaign, they need to fill it with products, they can just ask our team, reducing their workload, making they can spend more time on making more interesting campaigns. Also, another part of the app, if you buy something, it opens up a new store page. So if you buy something from Nike, here's the new Nike store, shows you what you've purchased, shows you some related deals, opened up. Okay, well, we can have product recommendations there. This is reusing the same model that we had for the transaction emails. So simply thinking about how we can apply what we've already learned and scale it out to another touch point, we're able to affect another group of customers, or at least in a new context. And we're still battling around, so this is still within the same few weeks. Can we affect more content? So the deals team were making, it's top right, deals in the app homepage. So they were done validating that creating and showing deals in the app homepage was creating value for them. But was there a better way of showing them than just randomly? They said, well, we've used this simple model twice already. It's worked out pretty well. Why don't we try Thompson sampling for you? So we spent a lot of time over the previous 12 months trying to get our iteration speed faster and faster and faster. And we managed to get this model. It's reusing a lot of the same code, but we got a new model, basically, in production in under a week. And it increased the clicks on this type of content by 78%, which was just ridiculous. So what I really wanted to share with you or inspire you with are these three things. The value of starting small and learning fast. So we spent a lot of effort trying to learn. What do our customers actually want? What can we do with our data? What types of models will work? Don't get distracted by technical limitations. We were working with manual CSVs. And something is often better than nothing, especially when you already have a product. Having a simple model delivering value now has a lot of value than trying to spend all your time, months, trying to make a better model. Okay, but what are we doing now? We want to be able to recommend from millions to billion scale of content. And we want to do it in real time. How do we do this? Well, we're planning on doing this, and we're building this now. The MVP is end of May. We have two stages. The first stage, we figure out offline what is relevant for you. And the second stage is online ranking optimization, where you figure out from what is relevant for you right now, depending on what is happening in the world right now, and the interactions you're having with us in the app or in whatever other context right now. And it's going to be really cool to see how our customers respond to this and how far we can push this. This was like working with real-time data was one of the main drawcards that drew me to Klarna, so it's really nice we're finally getting there. And I'd really like to thank the team. Without their can-do attitude and just incessant optimism, none of this would have been possible. And time for questions.
Thank you. So it's kind of fun. Recommendation systems is one of the most classical machine learning algorithms that people put in production and get value from. And it's always the same. It's matrix factorization.
Yeah.
So really hard to beat. So squeeze in. We have time for questions, so I'll just squeeze 2 quick ones. So actually, you had reinforcement learning in production, you mentioned. So how is that working? What was that actually doing?
So it's Thompson sampling, so it's really basic. So we collect the views and clicks, we put them in, it basically uses them to parameterize a beta distribution and sample from that. So every time we get a request, we sample from that and order based on that score. But the data collection is happening in batch. We're experimenting with using contextual banders, where we're trying to get that to mini batches every 15 minutes. But at the moment, we're concentrating on this 2-stage recommendation system.
Okay. Interesting. So we had a question over there, I think.
Hey, Asli Rodin from Volvo Cars.
Hey.
It's a great journey that Klarna had. I think it's amazing, and thank you for the presentation. Just wanting to clarify, you were talking about different markets, like US markets, I don't know. Do you have different models for these markets? Or is it one global model you have? And the second thing is, do you take into account the returns of the products? Or it doesn't maybe affect Klarna, I don't know.
We have the same code with different data in different markets. So we'll have the same model, but the data that's used to train it is different in each market, and then we have a different endpoint in each market. Returns is something down the line. Maybe the retailers don't want to hear this, but for us, if someone has bought something, that's a really good signal that they like it. If they return it, it's a signal. That signal is more complicated. Do they not like it? Is it the wrong size? Did it not fulfill the function? It's an interesting but complex question. We do have people working with some of our merchants to try and reduce returns in Klarna, but that's not what we're working on at the moment.
Also, personalization, is it customer-based, or is it, again, different markets?
Well, it depends. Right now, it's customer-based and market-based, and we want to move. So if we know nothing about you, let's say, okay, but most people at this time in this area have done or want this. And the more we know about you, the better we can personalize to just you.
Thanks.
Do we have any more questions from the audience? Yes, one over there.
Thank you. Leon from Rise. So my question would be, you have a lot of visual displays in your Klarna app. And could it be that the visual display of how the product is displayed, in fact, impacts also the click-through rate? And did you look at maybe a certain style of image that is more successful than another image?
That is something we're going to be testing in the new system. We're going to have different types of visualization for the same product. And I mean, Netflix has learned this, that different visualization for the same shows, depending on if you've seen the show or not, or the time of day, does have an impact. And that's something we want to test.
Thank you.
Okay. I think that was the final question. Thank you again, Anil.
Thank you.